Hypothalamus artificial intelligence, HI. Digital transformation powered by real-time autonomous and intelligent algorithms. Presents the short conference, Cyclist's Artificial Brain. It corresponds to one of several short conferences, in which the advances of HI research are presented, on the topic of artificial brains and decision-making artificial intelligence. Not every artificial brain should be for an organization. The Cyclist's artificial brain, that could be built with $100, is an example of an artificial brain for a person, which must use the mental intelligence that he has accumulated. The goal is to accelerate the processes of calculation and data acquisition, to have a great journey. Specific objectives may be: minimize energy consumption for a fixed time, or minimize travel time for a predetermined distance. The artificial brain may consist of hardware, IPNONE, and CPU yard. I/O Raspberry. Databases, traffic, climate, and terrain. Data acquisition, GPS and a mathematical model. A review of existing mathematical models for velodrome cycling suggests that cyclists and cycling coaches could benefit from an improved simulation tool. Dynamic mathematical models have been developed for cycling, which include calculated slip and steering angles, and thus allow estimate variation in rolling resistance, which means calculating the rider's energy expenditure. The paper A mathematical model for simulating cycling, applied to track cycling, shows a model that can be used to optimize cyclists' performance in a journey. Figure shows forces on the cyclist viewed in a direction parallel to the ground surface and perpendicular to the direction of motion, where beta is the angle of inclination of the ground surface. Lambda is the vertical tilt angle of the rider's direction of movement. F lambda is the consequential component of the cyclist's weight, acting in its direction of movement. Fd is the aerodynamic drag force. Fr and Fn are the rolling resistance and normal contact forces, respectively, where subscripts 1 or 2 refer to the front or rear tire. Ff is the propelling force acting on the contact area of the rear tire. Fx is the horizontal component of centripetal forces, Fc, and drag, Fd, forces. Phi is the sum of the forces acting on the cyclist at a lambda angle, with respect to the vertical and perpendicular to the direction of movement. Both Fx and Phi have components that act on the plane. Omega is the angular velocity of the rider and the bike. Figure shows forces acting on cyclist in a plane perpendicular to their direction of motion, lambda to the vertical. The image presents the superimposition of the two figures above. The figure shows the speed variables of the rider and the bike in a plane parallel to the bike frame. The graph presents the comparison of the simulated speed and the recorded speed for cyclists who competed in the 3-kip in the ETC 2017. 3-kip is associated with 3 kilometers of individual pursuit. Table present a comparison of actual and simulated split times for the 3-kip events at the ETC 2017. The error associated with the simulation's prediction of completion times and, more importantly, split times is lower than in any previous comparable study. The model was able to predict the completion time on a 4-kip with an accuracy of 2% and the individual split times, 0 to 1 kilometer, 1 to 2 kilometers, 2 to 3 kilometers, 3 to 4 kilometers, with a slightly higher error than that. From this dynamic model of the resistance faced by the cyclist, an optimization model can be formulated, which minimize the energy consumed on a route, with a given length, by linking the origin and destination, or minimize the time consumed with a certain amount of energy, which the cyclist has available at the beginning of the ride. The image presents the artificial brain of the cyclist. Everything can be connected. The components are: cellular phone for control and cycling communications with the outside world, it is, traffic database, for example Waze, hydroclimatic database, route database, and cyclist mathematical model. The entire artificial brain can function autonomously and permanently, in real time, on a Raspberry Supermini computer. Communications between the iPhone and the Raspberry can be done via Bluetooth. If you want to organize a route in which several coordinated cyclists travel, it is possible to synchronize the artificial brains through an autonomous conversation between them. Finally, There are now in the world machines that think, that learn, and that create. Moreover, their ability to do these things is going to increase rapidly until, in the visible future, the range of problems they can handle will be coextensive with the range to which the human mind has been applied. In 1972. In the book Human Problem Solving, wrote by Alan Newell and Herbert Simon. Thank you very much for your attention.